Hi again, class. So this lesson is about scientific notation. Scientific notation is a way that we express values that are either extremely large or extremely small. So in science, and in particular physical sciences, you always have a little bit of a tension between what is very large. So for example, the scales that we may talk about with astronomy or astrophysics, and what's very small, what we would currently talk about in terms of the size of the atoms, electrons, neutrons, protons, and subatomic particles. So I've just got two values here which are common in physics, and both of those are expressed in what we term scientific notation. So the first value is the speed of light. The speed of light is the fastest known speed in the universe. Okay, so nothing travels faster than the speed of light. And that speed is expressed as 2.998 times 10 to the 8 meters per second. Now, for reference, what that would mean, if you were traveling at the speed of light, you could probably circumnavigate, which means go around the length of the equator, or travel around the equator, 8 times in 1 second if you're traveling at the speed of light. So it's extremely fast. And what we have here is the charge of an electron, so the electric charge that an electron carries. And this is actually very, very small. So this charge is expressed as 1.609 times 10 to the negative 19 coulombs. Now remember, we were talking about the negative powers referring to a fractional end of the point. So to get some reference why these two values are so different as far as scale is concerned, what we can do is we can write them in what we would normally write them in our standard form. So if I was writing this, okay, 2.998 times 10 to the 8 meters per second, what I would actually do is this 2.998, and the decimal place is quite important here. What I'm going to do is I'm going to move that to the left 8 times. Okay, so I've moved it 5, 6, 7, 8. So if I count here, I've got 1, 2, 3, 4, 5, 6, 7, 8. And what I'm going to do here is I'm going to fill in my little leaps forward with zeros. So what that actually equals is 29800. I've got 5 zeros following. Okay, and we normally break them up into 3 sections of 3s because we count in, not so much hundreds or tens, but we count in thousand, millions, billions, and that's why the commas are put in every three digits. So 1, 2, 3, 1, 2, 3. And that's how fast the speed of light is, which is extremely fast. So if I was going to say that as an actual value, well, that's 299 million, okay, or close to 300 million meters per second. So over every second, you would travel 300 million meters, which is extremely fast. When we talk about our electron, however, we start with the term 1.609, and what we do is we're going to go back 19 times, which is going to be extremely, I'm not going to do that, but you would get a value that's going to have several zeros, okay? And it would continue on to here. Okay, so you can see the difference, and I just want you, don't worry about what we've done to get the values, but I just want you to appreciate this is very large, okay, very large and very fast, but that's very large, and the value here is very small. This is extremely small. Okay, so there's a difference. Now, large values, just note this, there will be positive, the power will be positive, and in very small values, the power will be negative. Okay, so what we're going to focus on is writing a large value in scientific notation. So what I've got here is 7520, okay, with a lot of zeros following. And if I was going to place a decimal point here, that decimal point would go there. And what I'm going to count is how many times do I need to move that decimal point, okay, just before the first digit. So I've moved it 1, 2, 3, 4, 5, 6, 7, 8, 9 times. And I can then write this value as equaling 7.52 times 10 to the 9. Okay? That's how we write a very large value in scientific notation. If I talk about a very small value, okay, so I have here 0.0000267. I again want to move my decimal point, but this time I'm going to move it to my left. And I'm going to move it in front of the first non-zero digit. Now I've moved this 5 steps towards the left. Okay. So then this expression, and this is very small, so I'm going to write this as equaling 2.67 times 10 to the negative 5, because it's small and I moved the decimal point to the left. Okay, let's go to the next page. So what I'm going to look here is I'm going to write a normal value from scientific notation. So this is the value that I'm going to write, but I might write this as 6.371 times 10 to the 6. This is the radius of the Earth. Okay. Okay. Let me just go back for a moment, just check on something. Yep. So this value, what I'm going to do is I'm going to start with my 6.371, and it's positive, so it's going to be large. And I'm going to move my decimal place 1, 2, 3, 4, 5, 6, okay, because that's what it asks us to do, okay, the powers 6 times, and then I'm going to put 0 terms in here. So my answer, as we've got here, is 6371000. Okay, and that's actually the radius of the Earth in meters. All right, and writing a normal value from scientific notation, what we're going to do here is we've got this value. Now I'll write this in scientific notation. So this will be times 10 to the 7. Okay, this is actually the wavelength of I believe this would be probably green or yellow light, okay, in meters. And what we're going to do, and it should be to the negative 7. So what we're going to do is we're going to start with 5.5 that we have, and then we're going to move this back 7 times. Okay, so we move the back 5, 6, 7, and we're going to put a 0 under each of these. So 1, 2, 3, 4, 5, 6, 7. Okay, and our decimal point would go there, and we would have a 0 there. Therefore, our value should be equal to 0.00055. No decimal point at the end. Okay. Let's go to our next page. So sometimes we'll be asked to deal with scientific notation where we're either adding or subtracting. So if I have something like this, 3.7 times 10 to the 6 plus 4.2 times 10 to the 6. Well, this has a common factor of 10 to the 6. So I can write this as 3.7 plus 4.2 all times 10 to the 6. I just equate what my numbers are going to equal here. So this will give me 7.9 times 10 to the 6. And there we have it. If you're dealing with values that have, let's say, 3.7 10 to the 6 plus 4.2 times 10 to the 8, which value is our larger of the two? This 4.2 times 10 to the 8. What we want to try to do is write this in terms of 10 to the 8. So this 10 to the 6, we want to try to convert it. To be able to do that, we have to have 6 plus 2 more. So we're going to take 1, 2, okay, and we're going to put a 0 and the decimal place goes here, okay, and this will give us, let me put it here, 0.037 times 10 to the 8 plus 4.2 times 10 to the 8, and this ends up equaling 4.237 times 10 to the 8. These kinds of questions, these type of questions, you're probably best to try to do them on your calculator, okay? But there is a method to the madness if you are trying to work these out. The other type of problem that we can get is when we're multiplying two terms. So if I have, for example, 2.0 times 10 to the 6 times 4.2 times 10 to the negative 2, we can see what this is going to be. The first thing that we're going to do, just like we would with our index laws, we're going to combine the numbers first up. So we're going to say 2.0 times 4.2, and then we're going to say 10 to the 6 times 10 to the negative 2. Now, we're going to work out this term first. That's going to give us 8.4, because 2 times 4.2 is 8.4. And then we're going to say that our basis for these two numbers are the same. So what we're doing here is we're going to add the two terms, okay, the powers, and we're going to have 8.4 times 10. 6 plus negative 2 gives me 4, and that's our answer. All right, so I'm just going to switch over to the calculator for a moment. So just bear with me whilst we're just bringing it up, just so that you can see it. and I'll show you how we deal with or write scientific notation on the calculator and how it's received. So what we're going to do is I'm going to pull my calculator to this side. I'm just going to add a graph, and let's say that I'm going to the speed of light, 2.98, and I want to say times 10 to the 8. So what I'm going to do here is I must multiply. So you must multiply, and then you're going to press this 10 to the x and say 10 to the 8. And there we get our value coming out as to what that is equal to. All right. If I wanted to have something really large, let's say I had 3.4, control 10, we don't want a log, sorry, ignore that, but we want 10 to, let's say, the 16. We're going to get an interesting term that looks like that, 3.4 e to the 16. That e, especially a capital E that looks like that, that means 3.4 times 10 to the power of 16. So just remember, if your calculator gives you a capital E value like that, that E stands for 3.4, or not 3.4, the E stands for times 10 to that power. Okay, if I was talking about my last few problems, so let's say I had 2.0, okay, times 10 to the 6, and I was multiplying that by 4.2 times 10 to the, let me put it in, times 10 to the negative 2, okay, I get 84,000, or 8.4 times 10 to the 4. We could convert that as a scientific notation into scientific notation form. Okay, so we'll leave it there for today. Continue work. I know you girls are doing great, so just keep on working away. Thank you.